sometimes. Okay, chapter 3-2. Yesterday, I talked about graphing, right? I gave you 4 methods to find the point of intersection of 2 lines out in space. Yes?
Yes.
We talked about graphing, linear combination or elimination, substitution, and determinant are the 4 methods. Okay? Yesterday was graphical. Today is going to be linear elimination. Linear elimination, method used to find the intersection point of 2 lines in the same coordinate plane. What is this also known as? You'll hear me refer to it as linear combination or linear elimination. Okay? Whenever I say elimination, that's exactly our point. It is our game plan. Our goal is to eliminate a variable. Okay? Now, the equations must be lined up with x's and y's under each other in the following form. ax1 plus by1 is equal to c. ax2 plus by2 is equal to c. What's up with the 1s and the 2s?
First and second.
First equation, second equation. So if I had ax10 and bx10, what would that mean? Or by10? What would the 10s indicate there? I'm on equation 10. Does that make sense?
Yeah.
Okay? No. Our goal today is to examine the coefficients of the variables to determine which variable is easier. And this is the key, guys. We want it to be nice and simple and easy for us. And the only way that we can do that, anybody see my floating tools anywhere?
No.
Me either. The only way we can do that is by actually finding the LCM, okay? So I want the LCM and I also want the easiest way, okay? Sometimes there's no easy way. Sometimes it's just ugly, okay? Sometimes it's very simple, okay? So, the coefficients must be opposites. They have to be opposites. If they are not opposites, they will not cancel out. Okay, and our whole game plan is to cancel out one of the letters. Who needs highlighters?
Yeah, I was thinking, I was really hoping that was a good.
Watch out. Okay, everybody's got highlighters that need them? Okay, the coefficients must be opposites of each other, so when you add them, they cancel out. This is so unbelievably crucial. Are you hearing me? So important. Okay?
22 page 1.
Yeah, really?
Yeah.
There we go.
They're all page 1. No. Then page 3.
Okay, go to the next slide.
Page 1.
Everybody complains that I make them too small. So I was super duper nice, and I made this one really big with your steps. So you have no reason not to follow the steps. You have to read and follow the instructions. Read and follow the instructions. Step 1, calculate the LCM of the x's. Step 2, calculate the LCM of the y's. Step 3, determine which variable is easier to eliminate according to the least common multiple and the current value sign. Okay, what do I mean by the current value sign? I need my signs to be opposite, correct? So if a sign is already opposite, is that one step I don't have to worry about anymore? It is. So you want to say, do I care? And EJ may be different than what Haley is, than what Shauna will be, than what Leisure will. This is the wonderful thing about linear elimination. You all can do it 5 different ways, and you all can get to exactly the same answer. Does everybody understand that?
Yes.
So your work, if it looks exactly the same as somebody else's, what is Yoder going to think?
Guitar.
Little tita, right? Okay, multiply the equation by the value needed to get your plus or minus least common multiple on each equation. Again, you want them to cancel out, so I need a positive 6, a negative 6, a positive 10, a negative 10. Do we understand that? Add the equations together to cancel out the coefficients. Solve for the variable that is left. Plug and chug the found value into an equation to find the remaining variable. Now, you don't have to use the original equation. But it is best to use an original equation unless there's fractions in it's ugly. Because if we have fractions, what do you think we're going to do? Do you guys want to deal with fractions or do you want to eliminate the fractions? You want to eliminate it. And I'm going to show you how to do all of that here in a little bit. This is your point of intersection, your POI. I will write POI all the time. Okay? Point of intersection. We talked about that yesterday too. All right, so next page. First example. Step 1, what's it say to do? Okay, so what I want to do is I want to find the least common multiple of my x's. So my LCM of my x's, 4 and 1. This is a 1 here. So what is my least common multiple between 4 and 1? So I need to do my multiplication tables in my head. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3. So what's the first factor they have in common, first multiple? 4. So this is going to be plus or minus 4. So if I eliminate x, I have to have both coefficients be a plus or a minus 4. Go to your y's. My least common multiple of my y's. I have a 1y and a negative 2y. So what is my least common multiple between 1 and 2? 2. So folks, which one would you rather deal with? Would you rather deal with 4s or with 2s? 2s look like they would be easier. Now let's look at the equations. I have opposite signs on my y's, don't I? Isn't that helpful for me? Whereas with my x's, do I have opposite signs on my x's yet? No. Okay. So what we're going to do is we're going to eliminate the y's. So we're not going to choose the x's, we're going to choose the y's. So I need a plus and a minus 2. Well, what do I currently have? I have a negative 2. So what do I need the other equation to have? A positive 2. So what do I multiply 1 by to get 2? So I'm going to multiply the whole top equation by 2. Do we see that? And I'm going to distribute that. So 2 times 4 is 8x. 2 times 1 is 2y. 2 times 5 is 10. And I'm going to bring down my other equation. And what am I going to do now? I'm going to add straight down. So 8x plus 1x is 9x. 2y minus 2y cancels. That's our point. 10 and 8 is 18. Can I solve this equation now?
Yeah, divide by 9.
I'm going to divide both sides by 9. And I get x is equal to 2. So, according to my steps, I've added them, and now I solve for the variable that is left. Now, what do I do on step 7? Plug and chug into what? One of the originals. So I'm going to come back here, I'm going to take one of my original equations. Does it matter which original I use? No. So which one do you feel lucky with?
4.
The 4x plus 1. So we're going to take the 4x plus the 1, y, which is equal to 5, and I'm going to plug in that x is 2. Do we see that? So I have 4 times 2, which is 8. And now how do I solve this? Subtract 8 from both sides because I'm solving for y. And I have y is equal to negative 3. Have I found my x and my y?
Yeah.
I have. So you know what my POI is? The set containing the point 2, negative 3. This is the point in space where these two lines will cross. Does that make sense? Yes?
POI.
Point of intersection.
We already over that.
Yes. 2 days in a row.
I missed the last part of that. Alright, it did.
He knew that, he went in here.
Huh, I wonder if that's in
Because you said it like 5 minutes ago.
It's not funny either. It wastes my time. Okay, what do I do? I need to find the least common multiple of my x's. So if I'm looking at my x's, I have 3x and 2x. So what's my least common multiple of my x's?
6.
I I need a plus or a minus 6. What is my least common multiple of my y's? I have 4 and 3. What is that? 12. Very good. So, let's look at them. Would you rather have a number of 6 or a number of 12? Generally speaking, you guys are always going to choose the smaller number, right? Because our brains work better with smaller numbers. But there are times whenever it's easier to deal with the larger number because you only have to multiply one equation by a value. In this example, you have to multiply both equations by a value, don't you? Okay? So we're going to eliminate x, and make sure that you know that you're eliminating x. That way you have it in your brain and you know, because you know what we're going to next is 3 equations with 3 unknowns. Okay? So it's really good to develop this procedure now and be very good at it so that whenever we get to the 3 equations and 3 unknowns, it's like second nature by then. Okay? Because I'm trying to get plus or minus 6, so I don't want to look at the y's. I need to focus on my x's. By focusing on my x's, the x's will fall out and I'll have just y's left. Does that make sense?
Yes.
Okay. So, I need to have a plus or minus 6x on the top equation. So what do I multiply 3x by to get myself a plus or minus 6? 2 or negative 2. I'm going to go ahead and multiply the top equation by 2, which means that's going to be a positive 6. So what do I multiply the bottom equation by? A negative what? Negative 3, because I have to turn that into a 6, and my coefficient currently is 2 on it. Do we all understand that? Matt?
Where did you get your negative 3 at? Multiplying by the bottom.
I have to turn this 3. I have to turn this 3 into a 6. The only way I can do that is multiplying it by 2.
Yep.
I have to turn this 2 into a negative 6.
Oh, all right.
So I have to multiply it by negative 3. Does that make sense? Okay, good questions. So I'm going to distribute the top one here. 6x plus 8y is equal to 2. Do you see how I went clear across the equal sign even? Go to the bottom one. Negative 6x minus 9y is equal to negative 21. Now what do I do? Add straight down. The x's cancel out. Did we do that on purpose? Yes. So now what's 8 yo-yos minus 9 yo-yos? Negative 1 yo-yo is equal to? What is 2 minus 21?
19.
Come again?
19.
Negative 19. So now I need to divide by negative 1 to get y is equal to positive 19. There's my y value. Now what do I do? How do I find x? Take one of my original equations. Does it matter? No. 3x plus 4y is equal to 1. And what do I know?
Y is 19.
That y is 19. Now you guys all have your calculators in front of you. I have 3x plus 4. I plug in the 19. What is 4 times 19?
36.
No, it's not. 76. I subtract 76, and I get 3x is equal to negative 75. And divide by 3. So what does x equal? Negative 25. So guess what I just found?
Your POI.
I found my x and my y, so I found my POI. My POI is the set containing the value negative 25, 19. And this is the point out in space where these two lines will cross. Now, if we were to be doing the graphing method, would this be in your viewing window?
No.
No, you'd have to zoom out, wouldn't you? Okay, do we all understand that? Okay, let's keep going. So talk to me. What do I do? LCM. What's my least common multiple between my x's? Plus or minus 6. How about my y's? Plus or minus 9. Which one would be easier? They're about the same, right? It really doesn't matter. No, neither one is more evil than the other one. This one already has a 6 and the bottom one already has a 9 in it. So all we have to do is figure out what we're going to do here. So we're going to eliminate which one, guys? You want to deal with the x's or the y's? You want the x's. Okay, so we are eliminating x. Notice I'm putting that in my corner over there so that I can stay on task, right? Okay? We're all taking notes, correct? Because if we don't, Yoder's going to stop copying the notes for you. Okay, so what am I going to need? Currently in my denominator, I have a 6x, not my denominator. My second equation, I have a 6x in it, correct? So what's my first equation's coefficient have to turn into?
Negative.
A negative 6x. So what do I multiply that by to get negative 6x?
3.
I need a negative 3 here. Do I have to touch my bottom equation? No, I don't. So if I distribute this, I get negative 6x plus 9y is equal to negative 18. Am I going to touch my second equation? No, so bring it down. And what do? Add straight down. Well, what happens whenever I add negative 6x and 6x? That cancels. What about 9y, negative 9y? So I'm left with 0 on the left-hand side, aren't I? Does 0 equal, what's negative 18 and 9? Is that a true or a false statement?
False.
That's a false statement. So what does that tell you about these two lines? They'll never cross. So if they never cross, what type of lines are those? There's no solution because these are parallel lines. That is a false statement. If you get a false statement, folks, that means the lines are never going to cross out in space, which means these lines have to be parallel. Does that make sense? Do we all understand that? Okay? Excellent. Next. 2x minus y is equal to negative 1, and 3x plus 4y is equal to 15. Off the top of your head, without doing the least common multiples, which one do you think would be easier? EJ, why do you think the y would be easier? Because there's a 1 here. Every time you have a 1, that means you only have to multiply one equation by it. Does that make sense? And my signs are opposite, aren't they? This is a negative 1y, this is a positive 4y. Do we see that? Now let's do our least common multiples. What's my least common multiple by x's? Plus or minus 6. Would I have to multiply both equations by a value? If I wanted to eliminate the x's, would I have to multiply both equations by something? I would. Is that fun for me? No. Why? More room for mistakes, right, when you distribute. Go to the next one. Least common multiple of your y's would be what? Plus or minus 4. Which one looks easier? It is the y's, and we already knew that, so write it down. You're eliminating y. Okay? So I need to have a positive 4 and a negative 4. What do I currently have? I have a positive 4. So I'm not going to touch that bottom equation, am I? What am I going to do with my top equation? I'm going to multiply by positive 4 because I already have what? A negative there. So this is going to give me 4 times 2 is 8x minus 4y is equal to negative 4. Bring down my 3x plus 4y is equal to 15. And what do I do? Add straight down. 11x, the y's cancel out, and negative 4 plus 15 is 11. So what is x equal to? 1. So I found my x, so what do? Into what? An original equation. And I'm going to choose the top one because the coefficients are what? Smaller, right? I have 2, 1, and negative 1. Those are smaller than 3, 4, and 15, right? So I'm going to choose 2x minus y is equal to negative 1. And I plug in what I know. So I have 2 times 1 minus y. So that's 2 minus y is equal to negative 1. Subtract the 2. Negative y is equal to negative 3. And now divide by negative 1. y is equal to 3. So now I found my x and my y, so what's my point of intersection?
1, 3.
1, 3. Are we getting it? Are we, honestly?
That's sort of.
Okay, last one. What did I throw at you there?
Ooh. Sweet.
Ooh, fractions.
No.
Do we know how to make fraction equations look pretty?
Yes.
Okay, so right now, my eye is not even looking at that I have two equations. What my eye is focusing on is the fact that I have something of it going on there, right? So I want to make this bottom equation look pretty. So what am I going to multiply that by?
3.
I'm going to multiply that bottom equation by 3. So that's going to give me 10x minus 14y is equal to 8. Do you see that the denominator is gone?
Yeah.
And now I bring down my top equation, 5x minus 7y is equal to 4. Can I do this now?
Yeah.
I see where you're going. Give me a minute. Not everybody else is there. I heard two of you have alarms going off in your head. That's excellent. Okay. Now, least common multiple of my x's are what? 10 plus or minus 10. What's my least common multiple of my y's? Plus or minus 14. Which one's easier? 10. So we're going to eliminate x's.
And then there's something you already used.
Riggs, chillax. Okay? And now, I'm going to do my linear combination right away here, and I'm going to multiply my bottom equation by what value? By -2. So the top equation, I'm leaving it alone. My bottom equation is going to give me -10x plus 14y is equal to -8. And what happens whenever I add straight down? That's gone. That's gone. And I have 0 is equal to 0. Is that a true statement?
Yeah.
So we talked about the false statement being parallel lines. So what would be the true statement? What are our three types of equations that we have?
Same line.
You have one point of intersection, meaning they're consistent and they're independent. We have the infinitely many lines, meaning that they are consistent and dependent. And then we have inconsistent, meaning
Goes to the word.
there's no point of intersection, and it's parallel lines. So we've done a whole bunch of point of intersections. We've done one parallel. What do you think this one has to be? Infinitely many, right? So this is going to be x comma y such that 5x minus 7y is equal to 4. Choose an equation, and there it is. Why is that? Because every point on those lines are exactly the point of intersection because they are the same equation. Look at this. Haley was going crazy back there. So was Mutt. He's saying, no, this isn't going to work. Okay? I don't have to do any work here. I showed you the work because I wanted you to see that 0 is 0. Right? Okay? Now, if I take 5 and double it, I get 10. If I take 7 and double it, I get to -14. If I take 4 and double it, I get to 8. They are essentially exactly the same equation. Right? One's going to the prom, one's going to school. Their DNA, which is their slope and their y-intercept, are exactly the same. Does that make sense? Okay, tonight for homework. You guys know me? Practice A, 22 through 36. And this will be all. Just to make sure that you're aware of that, I'm going to type that in here. All.
We go on the back of the last page before?
Huh?
Or can we do it on the back of the last page?
No, you may not do it on the back of any other homework. Every assignment must have an exactly new sheet of paper to it.
That's what last page was.
No, last night's homework was not that. You were in section 3-1, 18 through 40.
Oh, yeah.
Do we have a clear understanding? Do not lose your notes because tomorrow I have the substitution on there. Do we all understand that?
You have a what?
I have the substitution notes on there yet for tomorrow.
Where is it?
Yeah. Okay. All right, now I want you guys to get out last night's homework. Who did it? Let's see it. Okay, let me go over them. Number 18. 18, what'd you get? Hey, excuse me. 18 was inconsistent. 20, independent. 22, inconsistent. 24, independent. 26, independent. 28, inconsistent. 29 was infinitely many. So brace x comma y such that. Oh, sorry, yes. 30 was 4 and then 5 over 2 or 2.5. 32 was the point 2, negative 3. 34 was infinitely many. So x comma y such that x plus 3y is equal to 6. 36 was 28 over 5 and over 26 over 5, which there should be decimal points that I'll have to get them in a minute. 38 was inconsistent and 40 was inconsistent. How did we do?
Pretty good.
Did we do okay? Yeah? Excellent. Tomorrow, when you walk in here, same deal. Get your calculators out, log in. We may use them, we may not use them, okay? Just make sure you log in.
We go next one.
Hey, Nate. Here, so